So hello students. In today's class, I'm going to discuss about the telescope. In my last lecture, I have discussed about the different types of microscope. That is simple microscope, compound microscope. Okay. So in today's class, I'm going to discuss about the telescope. Now, what is telescope? First of all, many of you knew already that it is used for seeing the distant object clearly. Okay, it is used for seeing the distant object clearly. Now, clearly and magnified. For example, binocular, where you can see the very distant object clearly with the help of binocular. Binocular also one type of telescope. Now, in telescope, it is mainly of two types. One is astronomical telescope, and other is terrestrial telescope. Now, what is astronomical telescope? First of all, you have to know there are many objects which is outside the earth, that is we can call it as a heavenly object. So to observe the heavenly object or study the heavenly object, we use the astronomical telescope. Okay, we use astronomical telescope. That means for seeing the object outside the earth, the telescope which is used to seeing the object outside the earth, that type of telescope is called astronomical telescope. Now, in case of astronomical telescope, it will give us the real and inverted image. Real and inverted image. So the question may arise, though it is give the inverted image, so it will be difficult for us to study the image, because it gives us inverted image. But the thing is, the heavenly bodies are all the bodies, heavenly bodies are round. So if it is inverted or erect, it does not affect the observation, because if you see the round object, if you turn the object in any direction, then it will look like same. It will not uh, arise any problem. Okay, so for with the help of astronomical telescope, we can see the heavenly bodies object. Okay, now second one is terrestrial telescope. Now, what is terrestrial telescope? The For observing the objects on our earth. Okay, the telescope which is used to observing the objects on earth is called astronomical telescope. Terrestrial telescope. So terrestrial telescope give us the erect image. Give us the erect image. For example, binocular give us the erect image. Okay, so terrestrial telescope is what? It is nothing but it is used to observe the uh, objects on earth. Okay, so in this chapter we will only discuss about the terrestrial telescope. In your syllabus, sorry, not terrestrial, it is astronomical telescope. Okay, there is only astronomical telescope. So now we are going to discuss about the astronomical telescope. Okay, so astronomical telescope is, first we discuss astronomical telescope refracting time. So the telescope may be two types, refracting or reflecting type. So we will discuss about the refracting time. Okay, so an astronomical telescope is consist of two lens system. So just like the microscope, astronomical telescope also two lenses. One is objective lens and one is eyepiece. So for objective, we place the object in front of objective, and from with the help of eyepiece, we can observe the image. Okay. Okay. Now, in case of astronomical telescope, we will discuss the two cases. We'll discuss two cases. Okay, so one first case is when the final image is formed at infinity. When the final image is formed at infinity, that is called normal adjustment. So what is normal adjustment? Normal adjustment of a telescope is the adjustment when we uh, place an object at infinity and the image will be formed at the infinity. When we focus the Okay, so we have to adjust the eyepiece so that the image will be from at the infinity. This is called normal adjustment. We have to adjust the eyepiece so that the image will be formed at the infinity. That is called normal adjustment. So just like the simple microscope, we will have to find the magnifying power. Now what is magnifying power? In case of telescope, it is given that the magnifying power of a telescope in a normal adjustment is defined as the ratio of the angle subtended by the image at the eye seen through the telescope to the angle subtended by the object seen directly. Okay, so it is the angle between the eye and the image, okay, formed by the image, that is beta. Here you can see in this diagram, this is beta. Okay, beta is the angle, and when the object seen directly, that is it is alpha. Alpha is the angle between eye and the object when it is seen directly, and when both the object and image I lie at infinity. Here you can see the object is at infinity and the image also form at the infinity. Okay, so this is the magnifying power of a telescope. Okay, it is also known as the magnification. It is also known as the magnification. So what is the magnification? The magnification is equal to, okay, m equals to beta by what? Alpha. M equals to beta by alpha. Here you can see is m equals to beta by alpha. So this is the magnification. Okay, so okay, so we have, so since the alpha and beta are small, so we can write here m equals to, we can write m equals to 10 beta by 10 alpha, 10 beta by 10 alpha. Since, why you can write this? Because alpha and beta are uh, alpha and beta are very small, so we know that for a small angle the angle is equals to 10 of that angle, so m equals to 10 beta by 10 alpha. Now we have to use the triangle c a dash b dash to find the 10 alpha. So c a dash b dash, okay, 10 beta will be c a dash beta. You see this triangle c a dash b dash, so 10 beta will be, you can see 10 means perpendicular by base. So what is the perpendicular? A dash b dash, a dash b dash is the perpendicular, and what is the base? C dash a dash, c dash a dash. So the equation will be a dash b dash by sorry, c a dash c a dash. Okay, the equation will be this one. Again, oh, 10 alpha, sorry, 10 alpha is this one. 10 alpha means this triangle c a dash b dash. So 10 alpha will be perpendicular by base c a dash. Now what will be 10 beta? 10 beta is c dash a dash by a dash b dash. So 10 beta will be a dash b dash by c dash a dash. You can see here this perpendicular a dash b dash by c dash a dash. Okay, so this is the 10 beta, and this is the 10 alpha will be a dash b dash by c a dash. Okay, now if we put this value, it is, we put this value in equation 1, so it will give us m equals to c a dash by c dash a dash, c a dash by c dash a dash. Okay, so this is the magnification, magnifying, sorry, magnifying power of the telescope. Now we will use the sign convention. We will use the sign convention. What is c a dash? You can see from this diagram, c a dash. C a dash means we have to take in the right hand side, so it will be plus f naught, plus f naught, plus f naught c a dash, and c dash a dash will be, you can see from the diagram, c dash a dash, we have to measure this in the left hand side, so it will be minus fe, minus fe. So the magnification power will be the minus f naught by fe. So it is the magnifying power of a telescope when it is in normal adjustment. when it is in normal adjustment. Okay, so one more thing, it is found that when the telescope is in normal adjustment, the distance between two lenses is equal to the sum of their focal length. So when the telescope is in normal adjustment, so the distance between two lenses is we can find that the distance between two lenses is sum of the focal length, that is f naught plus f. Okay, so this is about the uh, astronomical telescope uh, when the telescope is in normal adjustment. When the telescope is in normal adjustment. Now go to the second case. The second case is when the final image is formed at the least distance of distinct vision. Here you can see its object is obviously object distance of the image, it is come from the infinity, and this image is formed here at the least distance, that is d. At distance d, d is what? Least distance of distinct vision. Okay, so the second case we have to discuss about the telescope, astronomical telescope, when the image is from at the least distance of distinct vision. Now here what is magnifying power? You can see magnifying power of the telescope is defined as the ratio of the angle subtended by the image at the eye by the image formed at the least distance of distinct vision to the telescope angle subtended by the object seen directly when it is in infinity. So just like the previous case, it is the angle between the eye and the uh, eye and object when it is it is placed in infinity, sorry, angle between the image and eye when it is from at the least distance of distinct vision to the angle subtended by the eye with the object when it is placed in infinity. Okay, so this is about the magnifying power. So m equals to here beta. What is angle between the object and image? It is beta, and alpha is the angle between the eye and the object. So m equals to beta by alpha. Beta by alpha. So since alpha and beta are small, so we can write m equals to 10 beta by 10 alpha. You see here m equals to 10 beta by 10 alpha. Okay, alpha and beta are small, so m equals to 10 beta by 10 alpha. Now from C A dash B dash triangle C, from alpha, what is alpha? C A dash B dash, this triangle C A dash B dash. What will be the alpha? 10 alpha. A dash B dash by C A dash. Perpendicular base. Let's check. A dash B dash by C A dash. Okay. So for beta, we have to use this triangle. C dash A dash B dash, C dash A dash B dash. So by how to 10 beta? Beta will be A dash B dash by C dash A dash. A dash B dash by C dash A dash. Okay, now put this value in equation 1. So m will be equals to c a dash by c dash a dash, a dash b dash, a dash b dash cancel, so it will be c a dash by c a dash a dash, c dash a dash. So again we have to apply the sign convention. C a dash. What is c a dash? C a dash, this is so not c a dash, c dash a dash, I think. C dash a dash. Okay, C C a dash, this distance, this focal length, this is focus, because the is here this image is formed at the focal plane. Image is formed at the focal plane. So this distance, let me show you. This distance, okay, is known as is f naught. F naught. Okay, this is the focal length of the object lens. This is the focal length of the object lens. Okay, now so c a dash will be plus f naught, and what will be the c dash a dash? C dash a dash, c dash a dash. It is, we can write, if you consider for this eyepiece, it is UE. It is UE. Okay, it is UE. UE means object distance of the eyepiece, so it will be minus UE. It will be minus UE. So m equals to minus f naught by UE, minus f naught by UE. Okay, Next, we know from lens equation minus 1 by uv plus 1 by ve equals to 1 by fe. We know 1 by u plus 1 by v equals to 1 by f, minus 1 by equals to minus 1 by v plus 1 by f. So according to new Cartesian sign convention, u is, we already got minus uv, and v is minus d, because the image will be formed at the least distance of distinct vision, and image is formed this side, on this side, so we have to calculate in left hand side, so it will be minus d, minus d. Put this value in this equivalence equation, so it will be 1 by minus ue plus 1 by minus d equals to 1 by fe. So minus minus cancel, 1 by u equals to 1 by fe plus 1 by d, 1 by fe plus 1 by d. Okay, so 1 by u equals to, if we take 1 by fe common, so here 1 plus fe by d. You can see here 1 plus fe by d. Okay, in equation 4 substitute the for 1 by u, we have, okay, just a minute, okay, this is not equation 4, I think this is equation 3. Okay, so I have read the mistakenly, so it is equation not 4, equation 3. Okay, equation 3, we have to put this value, we have to put this value, that is 1 by u equals to 1 by fe plus 1 plus fe by d. So if we put this value, then m will be equals to minus f naught by e fe into whole into 1 plus fe by d. So this is the magnifying power of a telescope when the image is formed at the least distance of distinct vision. Okay, so this is about the astronomical telescope. First case is when the image is formed at the infinity, that is normal adjustment, and second case is when the image is formed at the least distance of distinct vision. Okay, so just go through this my today's lecture, and if you have any doubt, you can ask me. Okay, so this is very simple topic in optical instrument. So one more class I will take uh, in this chapter, for this chapter, this optical instrument. After that I will start the wave optics. Okay, so just go through this today's lecture and previous lecture also, and don't forget to practice all this thing. Okay, if you not if you don't practice, then you will forget everything. Okay, you will forget everything, because this optical ray optics is very simple. It is just on the basis of geometry. Okay, so if you know about the geometry, then you can easily solve these problems. Okay, so I hope all of you well. So for today, thank you.